I'm looking at the wrong spot, but I don't see it.
Okay, I sent it in your email. Okay, so first I want to go over the problems from last week. I saw a couple of things that we just need to be on the same page for. So let me share this. Okay. Okay, so notice, remember, you don't want to decorate the part, and you want to put the dimensions toward the middle and then toward the top or the bottom. You don't want to have to, it's not decorating. Also notice the spacing, it's an even spacing. It's more than the 1/4 inch, but that's okay. The 1/4 inch is the minimum. And as long as it is even, you're okay. And then just straddle your dimensions. And then this, they are the right sizes, the right distances off the object. But you want to have it neat and centralized. Does anybody know why?
Adds clarity to the drawing.
Yeah, and if you have a whole bunch of parts on the same drawing and you have them decorated, it makes it real hard to read. So if you have them centralized, they are easier to read and easier to keep accurate. Make sense?
Mhm.
Okay, moving on. Also notice there's no 0.0 or anything for metric. You suppress the trailing zeros. Okay, this is the unequal limit dimensioning, the B. And same thing, you want to straddle and you want to have them all in one area. You don't mix tolerance types, like you don't go 1.002.999 and then have 2.00 plus or minus. You don't mix the two different types of tolerancing types. Make sense? Oops, go back. Okay. Okay, another thing, you need to make the decimal points line up. So that's a dimension setup in the tolerancing, and put dimension decimal alignment. Okay. And then This is unequal deviation. So notice you suppress your leading zeros and you have the plus and minus, and they should be aligned because the decimals are aligned. Okay.
Okay.
Now, say D. Okay, limit dimensions is same thing. You're going to have them with the limits. And does everybody know how to override in the in your properties?
Yeah, you go to properties, then down to the tolerance tab, and
You
then
got
you
it.
just go to upper and lower limit.
You got it. Yep. Okay, so that's the limit. And then this is the final one. And everybody was doing it just like the book. However, when you have your datums, the most stable position is generally your A datum. Okay, because that's the bottom. And it touches, and what it means by touching 3 different points, it means that it touches datum B at the back and datum B and then datum C. C is the back. So what it means from that is you have to rearrange the datums because the way they have the datums, it doesn't make sense. So it's forcing you to think about the problem and then also think about how it needs to be laid out. Okay. So this is saying there's 4 holes at 0.563, and it's got a positional diameter to A, B, and C, meaning it's got to be A and B and then C, which would be back here. Okay. Now C could also be back here. That's fine. It just depends on looking at the datum. This one says you've got a positional diameter of 0.25 to A, B, and C, and it's a diameter of 1.50. And then it's also saying it's got a positional diameter at maximum material condition at B. So it's got to be within the 0.010. Sorry, glasses are hard on a computer. Okay. So also, these are basic dimensions. Locations are basic. Does that make sense? As to why they're basic? Because they're a locational dimension. You're telling it where it needs to be by using your GD&T. So your flatness, it's bottom because it needs to lay flat. And then B is perpendicular to A. So this technically needs to be perpendicular to A. Also, do you guys know how to change your center lines? Override them in your properties so that you have a center line dimension? Because realistically, this basic dimension is to the center here. So it should be a center line, as are these. And there shouldn't be a gap. Like this, technically, there should not be. Not a center. Yeah, that should probably be pulled closer so that there's no gap. So do you know where I'm getting this information from? Anybody?
Would it be from the PowerPoint?
It's from the PowerPoint, but it's also from the rules or guidelines for dimensioning that come directly out of your book. I just took them and put them in the PowerPoint. They're also in the ADDA sheets. So any questions on these as to why they are what they are? Oh, yeah. You guys are so quiet. Okay. Anyway, so also notice these are all done in one drawing because you could copy them over and just dimension them differently. So they're just different sheets. Hold on, I'm pulling it up. This is getting old. Okay, so you guys see my drawing sort of under my properties. Okay, so all I did was create the same sheet over and change the name. And then they're all sheet one, like this is sheet 1 of 5, 2 of 5, 3 of 5, 4 of 5, 5 of 5. And then they're just all in model space, ready to go. So why do I share that? Because that way it'll cut down on all of your drawings. You know, you'll just have one drawing or one file instead of one for each one. Ooh, okay. So this week's drawings, we were originally supposed to meet with Ken in machining with his machining students. And that's kind of up in the air at the moment because of us not being in the classroom. So let's take a look at, no. I want to bring up more. Hmm. Okay, so if you're looking at this week's assignments, there are worksheets in here that we're going to work through. So you want to open these up and work on them. And it's just talking about what are these, okay? So you're looking at it. Let me turn it. Hold on, I was thinking. Oh, it did it anyway. All right, so let me share this. Okay. So it says label the elements A, B, C, and D that represent the fixture set up for a datum access. Okay. So it's saying what is A, what is C, label the elements. Okay. So you'll look at it and say, oh, this is this. Let me undo edit. Okay. So it's saying, what are these things? And you want to just label them as to what they are. Okay. And obviously it didn't like it when I opened it up. So anyway, select B. That's the datum, right? And what's this?
That'd be the datum of the surface feature.
Good. Okay. And C?
That is the center axis.
Center axis. Good. And A?
That is the uh, feature surface.
That, I think it's trying to, yeah.
Or the datum feature surface, whatever it's called.
Yeah, it's the datum feature. So it's saying, what is it? And that's all you're doing is going through and looking at them and labeling them, okay? You can do it probably on a separate sheet of paper unless you have an Adobe reader, the Adobe whole thing, you know, where you can edit it. Anyhow, so that's what we're doing. I think we do these. These are due on Thursday. Okay. We will review them in class. It says 5 o'clock, or midnight on Thursday. But we'll go through these on Thursday. Okay. And then these are your the problems that you're going to work on. And what it is you're going to draw these and put the proper tolerancing on them. So let me share. Okay, can you guys see chapter 13, problem 13.2?
Yep.
Okay, so what it's saying is you're going to draw this in proper, however it should be drawn, okay? And you're going to apply dimensioning and tolerancing to it. So on here, this is basically what an engineer might hand you, is this, telling you these are what you need to do. Okay, let me see if I can get it bigger. All right. So you've got concentricity and perpendicularity to A and B. A is the surface, and then B is this surface. Okay. And you have this slot here, it cut out, whatever. You've got the diameter, and it says the smaller diameter has a positional tolerance, no, a cylindricity tolerance of 0.005. It doesn't refer to the datum as because it's round. Okay. It's got the sizes. It's telling you basically how to read this. Okay. So where's the other one? Nope. Okay, so it has these on there. Looking at these, how should you orient this? Is this the left side?
That would be the front side.
No, that'd
Okay.
be your top side, because if it's cylindrical, you have to set it on your most stable space, so it should be standing upright.
Well, except that you're going this way. And if you look at you actually want it sideways because you're showing the cylinder at its side view. Remember, it's a cylinder.
Right.
So you would show it, this is actually pointed over here. And this is over here. So it's rotated around. Okay.
Should there be two views of it too?
Yeah, you need the part where it's round. And you can put that either as your front view or as your right side view.
Okay.
Okay. Does that make sense?
Yes, ma'am.
Okay. So that's that one. Then you're going to do this one. And how should this be oriented?
The first is that the surface that is facing us with the hole in the slot should be the front view. And
Say again,
that surface that has that hole in it,
right here.
yeah, that should be facing that should be the front view.
This is your front view.
Yep.
Okay. And then this should be on the left side and this should be on the right side. Why? This has more surface with your datum.
Okay.
Okay. So this has more points where it would touch your datum. So they're saying this is your A, B, and C. Well, B is the backside. But this would not be your datum because it doesn't really touch. You've got an angle. So this would be your datum.
So basically, the part would just be flipped around opposite.
Yeah.
Looking at it.
You know why it's put on here this way?
To confuse you.
No, it's put on there so that it's a picture of it, so you have an idea of what it looks like.
Okay.
Okay. This one, you need this information because it's an RFS, and it's it has a tolerance there, and then it has the slots, and it gives you a tolerance, RC4, with a nominal size. Okay, so where's the top, where's the bottom, and where's the right side? Any idea?
Would the top just be where those two holes are? That view?
Actually, this is your bottom. This is your
Oh.
top. The other side, where
Okay.
the slot is. You know why? More points on your, this has the most surface on your datum. So this would be the bottom, this would be the top.
Okay. Interesting.
I know it's confusing. But if you think about it as, okay, I'm going to put this down in the most stable position. Now, the only time that differs would be like this. because this is how it fits into the machine. Okay. So the surface isn't what's controlling everything to it. Everything is going off of this and this, because it's the perpendicularity that is important so that it fits into whatever machine it's going into. And then this one, this is the surface that would have the most contact with your, it's the most stable, but it has the most contact with your datum. And then you would have the top view. And this is your backside. And then this would be, well, the other side. Flip it over, it's the other side, the right side. Okay, and I've got like on here, A, B, and C, so that you see how the datums go. Okay, so how about this one? I can make it bigger. It says select datums and apply a positional tolerance of 0.01 mmc to the holes and a perpendicularity tolerance of 0.003 to the vertical leg of the angle. So what would where would the bottom be? Where would the top be?
So would the bottom be the left side of the part just because it has more contact with datums?
So because you've got a perpendicularity with this and your
Mhm.
holes and the backside, the bottom would be under here.
Okay.
Okay. And then you've got this here, but then you have perpendicularity to B. And you can, this would be B, would be the side. Okay. So it says perpendicularity to B, so it's back here. And then C. And do we need C? I don't think we need C. I think we only need A and B.
Yeah.
Yeah. Okay. Back here. And then you're going to do 15A and 15B from the AutoCAD advanced workbook. And they're in there. Okay, it says read chapter 15 in the workbook and work through the exercises and 2 exercises at the end, the examples in the end. Okay, and then upload them.
Did you put that in the middle of the chapter 15?
Thought it was in there.
Because I don't have that book. I need to, whenever I go down there next, I need to grab that book.
Find it and put it on there.
That'd be awesome.
No problem. Okay, yeah, I will find it and put it on there. Anything else?
Not that I can think of, not yet.
Okay. You guys, everybody else, anything?
Not yet.
Okay,
Yeah, not yet.
okay. You know where I
Yeah,
am.
nothing.
Let's see if I can find the chapter and put it on, okay?
All right.
Okay. And as far as tomorrow, I think we have to plan one more day being on Zoom, and then we'll plan on being in the class on Wednesday. Please do the intake for the Center for New Directions and send me the thing. Most of you guys have done it, but I need everybody to do it. We're going to be doing the the MBTI. It's basically, it puts whether you're introverted or extroverted, how you view things. We're going to do that as one of the classes so that you have a good idea of learning more about yourself and how you relate to things. But you have to go through the intake first before I can send you the link to do the MBTI. Now, when I send you the link, they said you need to make sure that you have like 30-45 minutes and just don't think about anything else. Just go through and use they say, don't think about it too much, just your first impression, if for the answer, however they're asking the question, just go with your first impression, because that's more likely your personality rather than thinking it through. There's no right or wrong or anything. It's just a personality inventory, basically, and how you relate to the world. So, and then we're not going to do it this week, but we'll do it next week. They're going to do it in the for our professional skills class. We're going to go through that. Okay. So it's kind of fun. It's fascinating to see what you come up as. Okay.
Yeah, I did that. I
Huh?
did that form like 2 different times, and I like
did?
screenshotted it, and it just never showed up. I never saved. So
Oh, but you did it?
yeah, I did it.
Okay, because in order for them to get to your test, you have to have gone through the intake. So if you did it, we're good.
Okay.
Okay. So, and that was
Should I come in? Should I come
Huh?
in on Wednesday if we're planning on coming in?
Well, we're doing professional skills and you've got math. So it's totally up to you. Anybody who feels sick, please don't come in. Please, please, please don't come in. Okay.
Okay.
Okay. All right. That's all I have, you guys. Let me know if you have questions. I will put this on there. So if you have questions going through the stuff, you can look at it or listen to it, however you want to do it. There are more ed puzzles, and I think we're getting close to being done with the ed puzzle part. We're getting close to being done with GD&T.
Thank God. I mean, all right.
Yay. Okay. Okay, well, that is all I've got for today. Let me know if you have a question, and I'm happy to get on. If you need me to go through something with you, we can get on Zoom. No problem with that. Okay.
All right.
Okay, you guys.
Good. Thank you, Alicia.
Anytime. You guys have a good day.
You too.
Thank you as well.
Okay, thanks.
Have a good one.
You too.